Hello, grade 12s. Welcome back to the channel, Science Therapy, hosted by the one and only science therapist, Uabuti Sos Ugobela we Maths. And without any further ado, let's look at these questions that we have here. Okay, so in today's lesson, we're going to be looking at the Gauteng Preparatory Examination paper for 2020. So that's your Maths paper 1. So we'll be going through all of this question paper in preparation to your Maths exam that you are writing on Friday, right? So we have our time, it's 3 hours, and then marks it's 150. Then this is 11 pages and one information sheet. Then we are given the instruction and information. They say read the following instructions carefully before answering the questions. So number 1 says answer all the questions. And then this question paper consists of 11 questions. Present your answers according to the instruction of each question. Then clearly show all calculations, diagrams, graphs, etc., which were used in determining the answers. Then answers only will not necessarily be awarded full marks. Then use an approved scientific calculator, which is a non-programmable and non-graphical unless stated otherwise. Then where necessary, answers should be rounded off to 2 decimal places. Very important instruction here. And then unless stated otherwise. Diagrams are not necessarily drawn to scale. An information sheet is included on page 12 of the question paper. Then number 10 says number the questions correctly according to the numbering system used in the question paper. Then 11, write neatly and legibly. Now, the one thing that I also want to add to this is that you do not necessarily have to answer these questions in a chronological order. That is to say, you don't necessarily have to start from question 1 and then all the way like that. You can start with any question that you understand as long as you indicate the question and number according to the numbering system, right? So if you feel like you understand question 2 better, then you can go to question 2. If you feel like you can answer question 4 from then you can go to that. Remember, the aim is to collect marks. It is not to write all of this in a chronological order. So it is possible that you might not finish the exam, but then understand one thing. We are here to collect marks. Whether you finish the exam or you don't finish the exam, make sure the ones that you understand, you have fully written them, and then you know that you have marks on that. So with all that being said, guys, let's begin with our question, right? So, okay, we have question 1. It says 1.1 solve for x. So this is algebra. And then we are looking at 27 marks. So if you want to score better marks in your question paper, you know that for algebra, you should aim to get everything correct. If it is not, maybe at least 90% to 95%. Right, so we have solved for x. It says 3x squared plus 5x is equals to 7. And then we are given here correct to 2 decimal places. Now, whenever you see this statement correct to 2 decimal places, this is a hint, guys, to tell you that you must use the quadratic formula. So if you are looking if you are looking for the hint on where to use the quadratic formula, this statement is best for showing you the hint that you need to use the quadratic formula. But then the first thing that you need to do before you can use the quadratic formula is to make sure that this is written in standard form. So that means I will have 3x squared plus 5x. And then now if I transpose the 7, it becomes minus 7 and then equal to 0. Now at this point, I can see this is in standard form. It's equated to 0. Now I can go ahead and say, since this is written in quadratic form, that means my a here is represented by this coefficient of x squared, and then my b is represented by the coefficient of x, then c is always the constant along with the sign, so it's negative 7, right? So that means I will have x is equals to negative b plus minus, and then this one is b squared minus 4ac over 2a, right? And now at this point, you just simply want to substitute this. Now, if you if you find yourself maybe having forgotten this formula, you can go to the last page, which is page 12. That's where all the formulas are. Then that's 5 plus minus. You have 5 square minus 4. Your A is 3, and then your C is negative 7. Over 2 times your A is 3. Now at this point, you need the aid of your calculator, and then you simply just punch and then SD that so that it gives you in decimals. So 0.91 or X is equals to negative 2.57. Now, in terms of where you will get marks, then your memo is saying there is a mark for each of the question or of the answers here. There is a mark for substituting into the equation. And then there is a mark for having to write this in standard form, right? So you know where your marks are. That's how you get that 4 marks, right? And then now let's proceed to 1.1.2. We are given 2x squared is equals to 9x plus 5. So that means at this point, what do we need to do? We have number 1, write it in standard form. So we'll transpose all of this to the left-hand side. So remember, whenever we are transposing, the sign changes, right? Is equals to 0. Now at this point, we can see it's in standard form. That means we need to factorize. But then I know that factorizing can be a bit of a problem, especially if your coefficient here is not 1. So what you want to do is you can still use the quadratic formula, right? But then one thing that you have to be smart with is that you can actually trick them to think that you actually factorized while you use the quadratic formula. So you put this in a quadratic formula, it gives you the answers, of course, and then your x is equals to negative 1 over 2, or your x is equals to 5. Now, there is a mark that goes to factorization. So you want to get that mark. How are you going to make sure that you have that step? From the answers that you have here, then reverse them. So you will say 2 times x, this will be 2x, and then it's equals to negative 1. Now bring this negative 1 over to the left-hand side. That's 2x plus 1 is equals to 0. Try to do the same thing for the other answer here. So that's x. If you take the 5 over to this side, that's x minus 5, and then equal to 0. Now you see this here. You want to write it here as your factors in the brackets. So this is 2x plus 1, and then this is x minus 5 equal to 0. Now you have factorized, just like any other learner that knows how to factorize. So your answers are then x is equals to negative 1 over 2, or x is equals to 5. Now when they give you your marks, you have full marks. So that's 1. And then here we're going to have 1 for factorizing, and then it's 1 mark for finding both the answers. If both your answers are correct, then it's 1 mark, right? So that's how you get your 3 marks. So pay attention to that trick there, right? So remember, they won't be able to tell if you use the quadratic formula if you don't show it there. Okay, now 1.1.3, we have x squared minus 5x greater than negative 4, right? First thing that you have to do now, you are dealing with an inequality question. So standard form, change color. So standard form, x squared minus 5x plus 4 greater than 0. But then you will remember from watching my videos on algebra that I said if the sign is facing that side, like this, it's a greater than sign, then your answer for the inequality is usually in this manner here. This is where you find x less than the minimum value or x greater than the maximum value. But however, if your sign is facing that other side, so it's a less than sign, then you normally have this as your answer, whereby you'll have your minimum here and then your maximum. So always bear this in mind. If you are looking at the sign of your equation there or your inequality and then it's facing that side, then always know that your answer will be presented in this format. Then if your sign is facing that other side, know that your answer will be presented in this format. So those are tricks that you need to know when dealing with this so that you are able to answer quickly. And then, okay, this one, it's not much of a challenge to factorize. It's just x minus 4 and then x minus 1. then greater than 0. Now at this point, you have to be very careful. You can't equate this one, so you'll go CV, critical values, and then right from the smallest value to the maximum value. So your minimum value is +1, and then your maximum value is 4. So in your mind, you are thinking of it as if it's an equation, right? You are thinking of it as if it's an equation. Your x would be 1, and again, your x would be 4. The minimum is 1, the maximum is 4. You write it like this. Now it's time for you to present it in either this format or that format, based on what sign you have on your inequality. Right, so now we have the sign facing that side. So that means our value needs to be x less than the minimum value, which is 1, or x greater than the maximum value, which is 4. Ta-da! Now you have your answer. If you want to present it graphically, this is it. This is where now you will have your 1 and your 4 here, and then you just shade this part here to indicate that your values are outside the critical values. So x is less than 1 and x is greater than 4. Then you have your, how many marks? 4 marks. So again, let's check where you get your marks. Where are marks being awarded? Then we have, for writing it in standard form, it's a mark. And then for finding your factors, it's a mark. And then for finding the critical values, it's a mark. And then if both the answers are correct here, you have used the correct annotation, then it's a mark. Okay, so 4 marks, just like that. Then 1.1.4 is x minus 3x to the exponent of 1/2 is equals to 4. Again, standard form. So you here, the whole question was emphasizing the point that you need to get this in standard form before you can do anything. So this is x minus 3x 1/2, and then minus 4 is equals to 0. Now, don't be alarmed by this. This is still the same as x squared minus 3x minus 4, right? You see the trend that takes place here is that now there is always a halving of the exponent here. There's always a halving. So if there is 2 here, then here there'll be 1. Because there is 1 here, 1 divided by 2, then we have 1/2. So that means, in other words, if I had x to the exponent of 4, there should be a halving of the exponent. That means I would have 3x squared, then minus 4. So always between the first term and the second term, there is a halving of an exponent. That's how you know that you are still dealing with a quadratic equation, right? So that means if we were going to solve this one like this is x minus 4, and then x plus 1, right, is equals to 0. That means, how would we solve this one then? So to solve that one, x minus 3x 1/2 minus 4 is equals to 0. Now I have to say x to the exponent of 1/2. You see that halving. So here we have x squared. Now I distribute x and x. Because I have x, now I have to distribute x half, x to the exponent of half, and then also here x to the exponent of half. So this will be minus 4, and then this will be plus 1 is equals to 0. Right, so same thing, right? Still operating in that level. And then now, from here, you can choose to just go like this. And then let me just erase here. You can choose to then have this being equated to this, to 0, and then or x to the exponent of 1/2 plus 1 equated to 0. Now this will be x to the exponent of 1/2 is equals to 4, or x to the exponent of 1/2 is equals to -1, right? Then to get rid of the 1/2 here, you can just multiply by the reciprocal of the exponent both sides, which is 2. And then obviously you'll be left with x. Then what is 4 to the exponent of 2? That's like 4 times 4, it's 16. But then we know every time we are looking at an exponent cannot be equated to a negative number. So this means this is not applicable. So your only value here is x is equals to 16, right? So that's how you were supposed to go about solving that question. So if you check it from the memo, they solved it differently, but then I just saw that this is the most straightforward approach. Okay, so here we're gonna get marks for the factors here, and then we're gonna get a mark for having to find our equation here, and then canceling that, and then also writing it in standard form. So how many marks was that one? 6 marks. So yeah, they have to give us our marks, guys. We want them. Give us our marks because this is also an acceptable approach. Yeah, so why didn't you think of that? Okay, so let's proceed. Then 1.2, show that the equation 2x, 2 to the exponent of 2x plus 1 plus 7 times 10 to the exponent of x minus 4 is equals to 0 has only one solution. Now, already we know that if we have something like this, we can just apply the K method, right? I don't like the K method as well, but then for the sake that most of you understand the K method, I will just stick to the K method. So I will say let. Now, the first thing that we have to discover from that is that this here can be written as 2 to the exponent of 2x. Okay, change color. So 2 to the exponent of 2x times 2 to the exponent of 1. Then plus 7 times 2 to the exponent of x minus 1 minus 4 is equals to 0. So based on our laws of exponents, that goes if I have a to the exponent of m plus n, this is the same as having a to the exponent of m times a to the exponent of n, right? So it's based on this law of exponent. So I did not just write that one. Then, okay, now remember 2 to the exponent of x is the same as having 2 to the exponent of x times 2 to the exponent of x, right? So now I can say let 2 to the exponent of x be k. So we're going to represent 2 to the exponent of x as k, mainly because we don't want to work with these exponents because they're a bit confusing. So we are trying to make this a quadratic equation that is clear to everyone to see. Then that means if I have to replace this, since this is the same as 2 to the exponent of x and 2 to the exponent of x, it would be the same as saying k multiplied by k, which is supposed to be k squared. I hope I'm making sense. Then this is k squared, then multiplied by 2, so it's supposed to be 2k squared. Then plus 7k, then minus 4 is equals to 0. Okay, so now your duty is then to factorize this. So again, if you can't factorize, you can do that trick with a quadratic formula. Then you will have 2k minus 1, and then this is k plus 4 is equals to 0. So that means my k here is equals to 1 over 2, or my k is equals to negative 4. But then the thing with using the quadratic formula, most of the learners then leave their answers like this. You have to then remind yourself, we are not solving for k, we are solving for x. Remember, you just used your k as more of a scapegoat, right? Then you need to then go back and say, the k was only to help me achieve getting the answers, but then the k is not the goal. We should calculate x. So that means you have to then remind yourself, but k is equals to 2 to the exponent of x. That means where there is k, I need to then replace back by 2 to the exponent of x. So this is 2 to the exponent of x is equals to 1 over 2, or 2 to the exponent of x is equals to negative 4. Now the 1 over 2 can be written in exponential form as 2 to the exponent of negative 1. And then x is equals to negative 1. But here, note this, whenever we are dealing with exponents, there is no exponent that can give us a negative answer. All exponents, if we are saying a to the exponent of m, then every time we know that our a to the exponent of m must always be greater than 0. At all points, there is no way there is no exponent that you can put in here and then it gives you a number that is less than 0. So that means this one is not applicable. And then now, there we go. We have only one solution. By saying this one is not applicable, that means there is no other x value. We only have one x value. And then voila, we have proved that this equation has only one solution, which is -1. All right. Okay. Then let's proceed to 1.3, simultaneous equations. Then, okay, we are given two equations for simultaneous equations. Then let us check. Let us square it. Then, okay, already here in equation 1, we can see that x has been made the subject of the formula, right? So this is equation 1. And then in equation 2, we have 2 minus x is equals to y minus 3, right? Now, remember, this is solved for x and y simultaneously. But then as much as it's simultaneously, we can't solve both of them at the same time. So we need to find one variable and then continue or proceed to find the other variable. So with that being said, that means we must focus on one variable at a time. So now that we already have an expression for x, and then here we have x and y, we are trying to work with one variable, we can take this equation number 1 and then use it to replace x here, right? So that now we are only dealing with y. Then, okay, we're going to write that as substitute equation 1 into equation number 2. But then here, this is where you need to be very careful with your maths, right? So note that I have minus here, and this whole thing here is an expression, right? So x can be replaced by the expression y minus 13, but then there's a minus here, so that means I need to put that whole expression inside the brackets, so that the negative here actually affects the y, and it also affects the negative 13. Then, okay, now this is equals to y minus 3. So I will continue solving inside here. This will give me so what is 2 minus y? It's 2, it's minus y. Negative and negative, it's positive. So I will have positive 13. If I add positive 13 to 2, that's 15. So I will have 15 minus y. I hope I'm not confusing anyone there. Then it's equals to y minus 3. Right. Now, remember, I cannot solve this while the square root is still there. So my problem is that I have a square root. Now, how do I solve that problem? Because remember, math is about solving problems. I need to get rid of that square root by squaring both sides. Remember, what I do on the left, I also need to do on the right. Now, the square on the left acts as a way to remove the square root. So that means I'm left with 15 minus y. But remember, on the right-hand side, there was no square root. So the square here will do a different jout. In this side here or on that side, it will actually expand the equation, right? Then I have 15 minus y is equals to y squared, then y times that, it's negative 3y, this negative 3y. So I will have minus 6y as my middle term. Then negative 3 times negative 3, that's positive 9. Now we can see that we are getting to something like quadratic form. Then, okay, so this is y squared. Then we can transpose the negative y. So let me write negative 6y. So I'm transposing over to the right-hand side. Then plus y, then plus 9 minus 15, then equal to 0, right? Then this is y squared minus 5y. Then what is 9 minus 15? What's the maths there? 9 minus 15. Now I don't know maths. Then it's minus 6, right? So that's minus 6 is equals to 0. Right, so we can still factorize this. Then come over here. So come over here. So this, when we factorize, it will just become y minus 6, and then y plus 1 is equals to 0. So y can either be equals to 6 or y can be negative 1, right? Okay, so now that I found my y values, I can use my y values to find the x values. Then this is x is equals to 6 minus 13. And then 6 minus 13, that's a negative 7. Or, again, if my y is negative 1, this is x is equals to -1 minus 13. So my x is equals to -14. So I'm simply using equation 1 to substitute my y values so that I get the x values. Then voila, I have 2 y values and then 2 x values. That's correct. And then, yeah. Now, the memo is actually awarding marks for the substitution. So now that I substituted into this, I would have a mark for that. And then squaring both sides, it's a mark. And then having to write this in standard form, it's a mark. And then having to find the x values, it's a mark. And then having to find the y values, it's a mark, right? And then also where the factors from here, it's a mark. So all of that, it's 6 marks. So they gave marks for substitution, squaring both sides, the standard form, the factors, the x values, and the y values. Remember, if both x values are correct, and also if both y values are correct, you get a mark. Okay, then just like that, we are done with question 1, right? So you want to be done with your question 1 within that time, right? So you take your marks as the time. So 27 marks, 27 minutes, but then you want to be done in less than that, right? So maybe you should aim to be done with this in just like 20 minutes, maybe. Then, okay, question 12 says, given the following quadratic sequence, write down the value of x in the sequence, right? So we want to write the value of x. So how are we going to write that? We already know this is 1, 7, 15, 25, and then this is x. We know how our quadratic operates. This is only 1 mark, but then, yeah, it's a lot of work. Then this is 6, and then 7 to 15. It's going to give us what? 8, and then 15 to 25, it should give us 10. So looking at this pattern here, 6 to 8, it's 2. 8 to 10, it's 2. So we already know that here, if we add by 2, we must get a value that must go in here. That should be 12. Now, if we say 25 plus 12, we should get the value of x, right? So see how we got that one. Then 25 plus 12, this gives us our value of x as 37, right? So 1 mark for that. Now, determine the expression for the end term of this sequence. So already we have that our x is 37, so we can just put it there. So that means our equation will start from here. We show this, and then remember that this is going in terms of the stages. So we have our second difference, our first difference, and then our quadratic pattern. So the second difference is always equated to 2a, the first difference to 3a plus b, and then the quadratic sequence to a plus b plus c. So that's how you get your a, then here you get your b, and then here you get your c. Now, how do we go about that one? So we are supposed to say 2a is equals to 2, then divide by 2, my a becomes 1. Now I want b, so I will say, note that we always use this first branch here. So we want to use the values from the first branch here. Then this will be 3a plus b is equals to 6. I already have a, it's 1, and then plus b is equals to 6. So if I transpose the 3 over to that side, that 6 minus 3 is equals to 3. Now if I want the value of c, that's a plus b plus c, I equate it to this, so that's 1. Right, so my a is 1, and then my b 3, and then c is equals to 1. 1 plus 3 is 4. If I say 1 minus 4 after transposing there, then my c is equals to -3. Now, you have to then write that in terms of the general formula an squared plus bn plus c. So your a being 1, that means you have n squared. Your b is 3, that means you have plus 3n, and then your c is -3, so that means that's what you have. So that means your equation now is something like this. N squared plus 3n minus 3, right? So for that, you have 4 marks, right? So you have 4 marks. So they mark you for finding the second difference. They mark you for finding the value of B, and then mark you for finding the value of C, and then finally having to write the equation. So that's how many marks? 4 marks. Okay. Then 2.1.3 says Wn represents the general term of the sequence for the first difference. Now, when it comes to number patterns, make sure that you read the statement at least 3 times to understand. Wn represents the general term of a sequence for the first differences. Note that it represents the sequence for the first differences. Determine the value of the n term of the quadratic sequence if Wn is equals to 50, right? Now, we had this 1, 7, 15, 25, and then 37. Then our first difference was 6, 8, and then 10, and then 12. And then we had our second difference is 2, and then 2, 2. One thing that you have to note, when they pull up with a quadratic sequence in grade 12, it usually goes with an arithmetic sequence, because if you can just check the nature of the sequence in the first difference, the first difference is actually an arithmetic sequence. Right. And then the second difference that you are seeing here. So it is very important that you note this trend. The second difference that you are seeing here actually represents the common difference of the arithmetic sequence. So if you are looking at this part only here, if you are looking at this part only, you can see that now we are dealing with an arithmetic sequence. So this 2 here is actually representing D, the common difference. Yes. Okay. So now we have that. Now, Wn represents the general term of the first difference. So that means we have already discovered that this is an arithmetic sequence. So Wn will be representing the arithmetic sequence. The general term of the arithmetic sequence is given by a plus n minus 1d, right? So what's your a? Your a now is 6, right? Because we are only focused on this part. And then your n has to be what? 50, right? No, they said Wn is 50. So we are actually trying to determine n. So Wn is what we have here. Then minus 1. Then your d is 2. So you put your 50 right here. Then this is going to be 50 is equals to 6 plus 2n minus 2, right? So 6 minus 2 gives us 4. We're going to have 4 plus 2n. Now we can take the 4 over to the side. That's 50 minus 4, which will give us a 46, right? So I transpose the 4 over to this side, then 2n. Divide both sides by 2. So my n is equals to what? So my n is equals to 23, right? My n is equals to 23. Now they're saying determine the value of the n term of the quadratic sequence. Of the what? Quadratic sequence, right? Determine the value of the n term. So now that we found that the n is 23, now we should then use this n is equals to 23 to actually find the value in the quadratic sequence. So that means, what's the equation again for the quadratic sequence? We had Tn is equals to n squared plus 3n. Am I correct? Yes, minus 3. Then this time I should say T23, and then this is 23 square plus 3 times 23, then minus 3, right? Because I understand that as you are looking at this, term number 1 of the arithmetic sequence of the first difference is between T1 and T2 of the quadratic actually. Then if you are looking for T2 of the arithmetic, it is actually between the second and the third term, right? So hence we are using that to say if we have found the 23rd term, then that means it should be between the 23rd and the 24th, which we can then use the 23rd there in order to find the value of the n term. So this here, if we punch it all into our calculator, we get 595. So the value of the 23rd term in the quadratic sequence is actually 595. Right, so for that, it's 5 marks. So they were awarding marks for having to reach to this point here, and then equating 50, yes, and then having to get your n as 23. So if you only did up until this part, you have 3 marks, right? Not bad. And then if you then realize that you still need to continue here because they said quadratic, then you were going to get your 2 marks, right? So for substitution into the equation here, and then for getting the correct answer. So if you only did this, 3/5. But then if you did all of this, that's 5, right? So you should always know where your marks are. Then let's proceed. 2.2, it says, consider the following. Now we've talked about this pattern here, whereby now they start to give you 2 alternating patterns, right? So consider the following. Assume that the pattern continues consistently. For 1 mark, they say write down the value of the 191st term of this sequence. Now that's a no-brainer because we can see that all the zeros are actually on odd places, right? So 0 is on 1, and then 0 is on position 3, 0 is on position 5, like that. So they all occupy odd places, and then 191 seems to be an odd number, so that means we're also going to have a 0 there if this pattern continues consistently. Then it says determine the sum of the first 500 terms of this sequence. Now you have to be very smart here. Remember, the 500 terms will be made of the zeros and also these other numbers here, right, that are forming a different pattern. Now, that means if we are making 500 terms, there will be 250 zeros, right? And then also the 250 of the other pattern here, right? That's one thing that you need to consider. So already you have the sum of the 250 zeros is just 0. If you add zeros, no matter how many zeros are there, it will just become 0. Right, so the sum of the 250 zeros is just 0. Now that means we are concerned about the other 250 terms that are remaining. So before anything, we should get the pattern that this other numbers are forming. Remember, we are not told, so it means we have to discover the pattern. So this to this to that, right? Now, if we can check there, we have -1/2, and then 1/2, and then 3/2. Now, obviously, if you try to divide these ones here, you would see that there is no common ratio, right? So it's not a geometric sequence. Now, let's try to find the difference, T2 minus T1. And then you will find that your difference is 1. Now, if you try to do it with this 3/2 minus 1/2, you also get 1. And then even here, you also get 1. So this has to be an arithmetic sequence, right? Now, knowing that this is an arithmetic sequence, we already know the formula that we have to apply for arithmetic sequence is what? So allow me to just write it over here. Then we will have Sn is equals to n/2, and then 2a plus n minus 1d. So this is the equation for the sum of the arithmetic pattern. Now, but then the n, I'm not gonna put 500 there. I'm gonna put 250, right, over 2. Then this is 2. My a value is -0.5, right? And then plus my n again, 250 minus 1. And then what's d? It's 1, right? Then you simply just grab your calculator and punch out of this. So the sum of the 250 terms is actually 31,000, right? But then remember we said the sum of the other 250 term, which is made out of 0, is just 0. So sum of 500 terms is actually sum of the 250 zeros plus the sum of the 250 terms. That gives us a sum of 31,000. So that's 0 plus 31,000, which would actually give us 31,000. So therefore, sum of 500 terms is 31,000, right? So you saw that it was not a very difficult question, just needed you to apply your mind. Okay, let us proceed. Let us proceed. Okay, so done with that one, 4 marks. Oh, I didn't show you where the marks are. Then, okay, they said it's a mark for getting the value of D. It's a mark for getting the value of D. It's a mark for having to substitute into the correct formula, which is the SN formula. And then it's a mark for having to get this one is 31,000. And then it's a mark for being able to say sum of 500 is also 31,000. So 4 marks. Okay, then here, now we are given a geometric series. They say consider the following geometric series, determine the value of K. Now with this, they did not mention, but then the assumption is that this is a convergent series. So I feel like they needed to mention, but then there was no other way to get it. The only way you can get the value of K is by using -1. R is greater than -1, but R is less than +1. So that is the condition for a convergent series, right? So meaning that we need to first get the value of R, right? So we can get the value of R by simply saying T2 divided by T1. Then our T2, 8, 1 minus K over 5 to the exponent of 2 over 4, and then 1 minus K over 5, then like that. So dealing with this, 8 divided by 4 is 2. And then here, because square here means that we can expand this twice. So this is 1 minus K over 5. So it will only cancel off with 1. So our R is being represented by 2 bracket 1 minus K over 5. Right. So I hope that makes sense. Then what we are supposed to then do here is put that R in the middle of this. So it's -1. And then we have 2 bracket 1 minus K over 5 and then less than 1. Right. So what you want to do now is do your maths, right? So you can start getting rid of this 2. So you can divide both sides by 2 in order to do that. Or you do that reciprocal thing. Since it's 2, you can multiply both sides by 1 over 2. Then this will give you -1 over 2. And then remember the 2 is out here. Then you are left with 1 minus K over 5. And then here we are having 1 over 2. But then again, you can cross multiply with the 5 both sides. Remember what you do on the left, you also do on the right in this one. So if you say -1 over 2 multiplied by 5, and then also the +1 over 2 multiplied by 5. So this will give you -5 over 2, and then less than 1 minus K, and then like this. So this is 5 over 2. Now remember, we are looking for the value of K, so you still need to take the 1 over to the side. But if you take the 1 over to the side, you must also take it over to that side. So if we say -5 over 2 minus 1, and then we are left with -K here, this is 5 over 2 minus 1 as well. Right, so whatever that you are doing here, you also need to do that side. Now, if we punch this into our calculator, we have -7 over 2, yes, and then here -K. And then this gives us 3 over 2. But now the one thing that you have to note here, because I have -K, if I want to write this as positive, I must simply remember, if I start dividing by negative here, the signs can't change and be like this. There's no such thing as this, right? You can't have K here and then the signs are facing that side. Your signs are always like this. Now, what is it that you're going to do? As soon as you divide by negative, you have to flip the values. So remember, if I divide by negative, this becomes positive, meaning it will jump over to the side. And then this becomes negative, meaning it will jump over to the side. So that means my K now is -3 over 2 and then +7 over 2, right? So that's how you should indicate that. Always put that in the back of your mind. Whenever you are we are dividing with the negative with this one, the sign cannot change. The sign cannot swap, but then you need to swap your values. Okay, yeah. So your value is this. Your answer is this. is this. So follow through how I got to that one, especially when we get to this part, we are dividing both sides by -1, but because we are doing so, the values, they swap. Okay, so that would give you a solid 4 marks. So they said it's a mark for finding the value of R in terms of K, and then it's a mark for having to discover that you need to use this convergence series. And then it's a mark for the correct critical values, so somewhere here. And then it's a mark for having to write the correct answer, having to do that. So 4 marks. Okay, guys, okay. Let's proceed. Then we have question 3. It says the first 3 terms of an infinite geometric sequence, right? So note we are given infinite. Whenever they're talking about infinite, we know we might consider to look at the formula for sum to infinite. Then of the sequence of 16, 8, and 4 respectively, in that order. Then determine all possible values of n for which the sum of the first n term of this sequence is greater than 31, right? So that means we are looking at a condition where Sn is greater than 31, right? So we can simply do that. Our 3.1, easy peasy. So we can simply do that by saying Sn is greater than 31. But then we know that our n, so remember we have 16, 8, and 4. So let's find the value of r first. So the value of r, t2 divided by t1, it's 8 divided by 16, which will give us 1/2. So the reason I'm looking for the value of r first, it's because this will help me determine the type of formula that I need to use. Remember, we have 2 formulas for Sn of geometric. We have a 1 minus r to the exponent of n, and then 1 minus r, where your r should not be equal to 1, obviously. Then all this, Rn minus 1 over r minus 1. Now, a lot of you tend to just pick any formulas from this, but then you have to understand that you pick this formula if your r is less than 1, and then you pick this formula if your r is greater than 1. So basically, you are just trying to keep the denominator as a positive here. So if you have your r being less than 1, then you can choose this. If you have your r being greater than 1, let's say it's 3 or 4, you can choose this one, right? Then that means the one I'm going to go with based on my value of r is this one here, because half is less than 1. Then a bracket 1 minus r to the exponent of n, and then 1 minus r greater than 31, right? Now, what is my value for a? It's 16. And then 1 minus my r is 1/2. So I'm looking for the value of n, right? So I'm going to put it that. Okay. Then, so first thing, to make sure that you don't have so much maths, so you can start by just finding the value to here. Then that's 1 minus half, it's half. And then now you have 16. 1 minus 1/2, and then n. This is half here. But then if you have your half, you cross multiplied with 31, then what you are going to get is what? So let's say we have 0.5 multiplied by 31. This is going to give me a 31/2. If I cross multiply here, it's 31/2. Now you also want to get rid of the 16 here, so you can divide both sides by 16. So divide this by 16. Remember, saying over and divide by 16 is one and the same thing. So if you say 31 divided by 2 divided by 16, this will give us 1 minus 1/2 to the exponent of n, and then greater than 31/32, right? So at this point, what you do is you can take this 1 over to that side. So you are left with negative 1/2 to the exponent of n greater than 31/32 minus 1. and then you can simply punch this into your calculator. You have 31 over 32 minus 1. So this will give us negative 1 over 2, then to the exponent of n greater than negative 1 over 32. Now you have negative here. If you divide both sides by negative 1, understand what happens, right? The sign changes because it's only one sign. There's nothing in between. The sign flips position. So now we have 1 over 2 and then n. Now the sign is like this because you divided by 1. So every time you divide by negative answer, the sign flips. Then you have 1 over 32. Now, you want to find your value of n. You can write 1 over 32 in exponential form, right? So if you only just take 32 and then punch it into your calculator, shift, and then factorize, it will factorize this to 1 over 5, right? So the 32 factorized is not 1 over 5, actually to the exponent of what? Of not 1 over 5, sorry. It's 1 over 2 to the exponent of 5. That's what I wanted to say. 1 over 2 to the exponent of 5. Because if you say 2 to the exponent of 5, that's actually 32. Right. So this becomes 1 over 2 to the exponent of 5. So even if you can punch it into your calculator, that's the value that you are going to get there. Right. But then now, why are we doing this? We wanted this to be the same basis so that we actually apply the law of exponents that says if the bases are the same, you can drop down the exponents, right? So if we drop down the exponents, that's n less than 5, right? That's n less than 5. Okay, so just like that, I found my 3 marks. So where were the marks? So they were awarding marks for having the correct substitution into the correct formula. And then they were awarding marks for the simplification. So correct substitution, and then simplification, and then also we have the correct answer. Okay, then let's proceed. 3.2 says calculate the sum to infinity of this sequence, right? So sum to infinity, that's sum to infinity is equals to a over 1 minus r, right? Then our a is 16, then 1 minus, the r is 1 over 2 as we calculated, and then all you have to do is punch this into your calculator, you get 32. So your sum to infinity becomes 32, right? So correct substitution and also the correct answer, that earns you 2 marks. Okay, so now let's proceed to question 4. So at this point here, if you got that 5 marks, so let's add, you got that 5 marks, you got the 19 marks, and then you got the 27 marks from algebra, you are already seated at 51 marks. So question 1, 2, 3, this is what you solve if you only want 30% of the paper. So 50 marks is about 30% of the paper. At this point here, you are now seated at a level 2. If you answer all these questions, you get them correct, you are now seated at a level 2. So that means you still need to push further to at least get level 4, 50%. Right. So now, let's go to question 4. We have this. It says given f of x is equals to 6 over x plus 2 minus 1. Write down the equations of the asymptote of f. Now we already know that this is a hyperbola, and then a hyperbola has 2 equations of the asymptote. So this will be given as x is equals to -2, because always this here, we need to know that if it's a plus, we write it as negative here. If it's a minus, we write it as positive. And then the other equation that we have is this one here, which is our horizontal asymptote. We take it as it is along with its sign. So it's y is equals to -1. Guys, you must always write it in the form of an equation. X is equals to -2 and y is equals to -1. Don't just go -2 and -1. So you need to write them in terms of an equation. Then 4.2 says calculate the y-intercept of f. We already know if we are looking for the y-intercept, then we make x 0, right? So that means this is y is equals to, so I'm just going to replace my f of x by y. And then 6, 0 plus 2, then minus 1. So if I say 6 divided by 2, that's 3. 3 minus 1, that's 2. But then I have to, the y-intercept is y is equals to 2, right? So they did not say write it in coordinate form, but if you do wish, it's 0 is to 2. Then the x-intercept, this is where we make our y 0, right? So for the x-intercept, we make y 0. So again, here we're going to say 6 over x plus 2, then minus 1. Our f of x, we're going to put 0. Now, every time you're solving this, start with this one here, the constant. Bring it over to the other side. So it's 6 over x plus 2, and then it's equals to +1. Now you want to cross multiply here, and then this will become 6 is equals to x plus 2, because it's just multiplied by 1. Any expression multiplied by 1 will remain like that. Now, if we take the 2 over here, this will become 6 minus 2, and then x is equals to 4. So that means we have this as 4 is to 0 if we have to write it in coordinates. Right, so now you have the x-intercept and the y-intercept, and also you have the equation of the asymptote. We should expect a question on sketching because this is hyperbola. And then we know when it comes to sketch, looking at your A here, it's positive. So you already know the kind of graph that you expect. You expect your graph to be on the first and the third quadrant, right? So sketch the graph clearly showing all the asymptotes. So let's start with your asymptotes. Every time you're drawing the graph, you want to start with your asymptotes. So remember your asymptote, your vertical asymptote is at x is equals to -2. So guys, the one that is saying x is actually the vertical asymptote. The one that is saying y is the horizontal asymptote. So do not be confused by the fact that x is horizontal on the Cartesian plane. This one that goes x is equals to -2 is the vertical asymptote. Vertical asymptole. Then y is equals to -1 is the horizontal asymptole. Right, so to indicate that other one, let me change color. So let's say we are dealing with the other one, the horizontal asymptote. So it's at y is equals to -1. We can predict it to be somewhere there. Right, and then we just indicate that it has to be -1 here. Sharp. Now, obviously, this sets stage to our intercept. So intercept, the y-intercept, we had it at what? At 2. So that's it. So remember, this is the original, it's 0. So at +2, we say it can be somewhere there, right? And then the other intercept was at +4. It can be somewhere there. Then all you need to do is join those lines, right? Join those lines. So if we join those lines, okay. Hey, don't disappoint me, my banner. Don't disappoint me, my banner. Hey, when it comes to a curve. Okay, yeah. Then you have something like this. Cool. But then that is not a hyperbola function if I'm only going to leave it like that. Remember, I also need to come in here in between my asymptote and write the other wing here, or the other curve. Now this becomes a hyperbola. So a lot of you just focus on this one and then you forget about the other one. Remember, if you only indicate it like this, it's more of a what you call, what's this, exponential function, right? But then a hyperbola function is this 2 here. So you need to indicate, even if it's not intersecting anywhere, but then it needs to be there. So, yep, then you can label it F, right? Then you are done. Okay, now 4.4 says determine the equation of the line of symmetry that has a negative gradient. Leave your answer in the form of y is equals to. So for that one, we normally use this method. For some reason, they call it the bus method. So I recently learned that bus is the one that wrote this textbook. What is Mind Action Series? So apparently came up with this formula to say that if you want to determine the line of symmetry, you can simply do it like this. So provided that obviously you change your f of x to y, but then if they say indicate the one with the negative gradient, then put this one here, only the ones in the denominator inside the bracket, and then have a negative just before that. So that means it's y is equals to negative in bracket x plus 2 and then minus 1. So this is y is equals to negative x, and then negative times positive is negative 2, then minus 1. Y is equals to negative x, then minus 3. Okay, sharp. That's it. Y is equals to negative x minus 3. That becomes our equation of the line of symmetry with a negative gradient. Now, if you're asking how would we do the one with the positive gradient? The one with the positive gradient, also using the bus method, it's y is equals to just x plus 2 minus 1. So you simply take it exactly as it is. So you just ignore the a value here. And then this is y is equals to x, 2 minus 1. That's a positive 1, right? And then you have it like that. So this would be the one with the positive gradient. This is the one that they're looking for with the negative gradient. And then, yeah, always when it comes to your hyperbola graph, guys, you should just collect everything. There is nothing that deep or difficult when it comes to a hyperbola. Just free marks. Okay, so nice. We have the 12 marks in the bag. And then now we are going to question 5, which is your exponential. Also, this one, you hear kids saying, yay, you're shy. Then, okay, write down the equation of p to the exponent of negative 1. This indicates the inverse of p in the form of y is equals to. So, okay, this we can indicate it by this. We have px is equals to log base 3x. We know that the inverse of a logarithmic graph is an exponential graph. And the inverse of an exponential graph is a logarithmic graph. So where you see a log, expect an exponential. Where you see an exponential, expect a log. And then how we do this is by saying px can be written as y, and then log base 3x. But then you can do this. You can say now, let y be equals to x, because that's the essence of an inverse. So with an inverse, you are simply saying your y value can become x and your x value can become y. And then this is x here, and then this is log base 3, and then we can have a y here. But then we know that in order to deal with this, whenever we are converting from log to exponent, we always have to take this here, and then it lifts up that as an exponent, and then we leave our y here as the subject of the formula. So you only need to know that law when it comes to log. You don't have to go through and then try to revise all the log rules, because you're not going to use them. So it's only this. Whenever you have a number here, this number lifts up this one to become an exponent. And then the number that you have here becomes the subject of the formula or the variable. Then this is 3 to the exponent of x. Now, just like that, you have your equation of the exponential. So this is now the exponential equation. So you just need to remember that first, let y be x. So where there is y, you put x. Where there is x, you put y. Then the number here, the base, lifts up this to become the exponent. And then that becomes the subject of the formula. So I hope it makes sense. Okay, now they are saying sketch in your answer book the graph of P and the inverse on the same system of axes. Show clearly the intercept of the axis and one other point on each graph. So we can have this, our Cartesian plane. And then for the original one, which is the log, we know that for the log, we can try to find the x-intercept by making this one 0. So this is log base 3 and then x, and then let's make y 0. So we are trying to get the x-intercept, mainly because we know that the properties of a logarithmic graph, so a log graph has an x-intercept, where else an exponential graph has a y-intercept, right? And then this can be solved by doing this. So we put 0 there as log base 3 and then x. Now the 3 here will lift up the 0. So that's 3 to the exponent of 0 and then equal to x. Then x is supposed to be 1. So that means we have a point here, right? Now, we know that for the log, this here acts as the what? As the asymptote, right? So this acts as an asymptote. Now, if you want to confirm that, you can say log, and then you try to put a 0 here. If you want to confirm that this here is the asymptote, you can try to put a 0 here. You will see that you will not get a value. It will say maths error. So that proves that that is the asymptote, meaning your graph will approach 0, but then will never touch 0, right? And then it will go that way. So it's supposed to then curve like that. If you want, you can get a certain point here. Say maybe if you substitute 3 and then you get a particular point, but then we are only concerned about the shape. Now, when it comes to the inverse, which was your exponential graph, you had y is equals to 3 to the exponent of x. Now, for this, we can try to calculate the y-intercept by making x 0. So this is y is equals to 3 to the exponent of 0. Y is equals to 1. So we know that it will have an intercept here, right? And then the asymptote for this graph always is being represented by this line here. So it has an asymptote here at y is equals to 0. So that means it would approach this line, but it would never touch this line. And then obviously it curves like that. So when you draw these two graphs, they should somehow look like a mirror image of each other because it's an inverse, right? So when you have to indicate, so you are not supposed to do this, but then I'm just trying to show you that if you had to put that line of y is equals to x here as your mirror, you would see that these two equations are just a mirror image of each other. So that means this indicates the inverse of p, and then this is p original. This is the log, and this is the exponential. So just like that, you have indicated your graph. Hallelujah. Then, okay, so that one was for 6 marks. So they said it was 2 marks for having to know the shape. So if you correctly have the shape of graph P, it's 2 marks. If you correctly have the shape of graph inverse of P, it's 2 marks. And then if you have clearly shown the point on P, which is this one here. So let's indicate that we have 1 here, and then we also have 1 here, right? And then those ones would be marked. So the values in here would be marked. Each value would be marked. And then that means 3 marks for each of the graphs. Okay, nice, 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 nice. Nice to know that. Then, okay, 5.3, it says, determine the value of x for which p of x is less than or equal to 2, right? Now, all you can do here, the px, remember, you know the equation, it's that log 3x, right? Then now they're saying it should be less than or equal to 2. So that means you can take the expression for that and then just say less than or equal to 2. So at this point, if you want the value of x, you leave your x here to be the subject of the formula. The 3 lifts up the 2 to become an exponent. So still your sign is less than or equal to, then 3 to the exponent of 2. So this is x less than or equal to, so this is x less than or equal to 9. But then remember here, so I do not want to write this here. Let me say my critical value is x is equals to 9. But then remember, I have to note something. With the log, I said x is equals to 0 is actually a what? An asymptote, because it never wants a value of x to be 0. Remember, when I said put 0 in here, you received a maths error. You got maths error from your calculator. So that means x is equals to 0 is actually an asymptote. That's a point that the log graph will never touch. So that means if I have to write this answer here or this solution, I actually need to put that in mind to say that now my x has to be an element from a number that is greater than 0 all the way to positive 9. So I can either write it that way or this way here. So x has to be greater than 0. Remember, the 9 has to be included, so equal 9. And then x has to be greater than 0, or x has to be less than or equal to 9, right? So because I'm considering the fact that as much as it can be less than 9, but then it should never be less than 0. It should never go to the negatives, because your logarithmic graph does not want you to substitute either a 0 here or a negative value. Whenever you do that, maths error. Okay, then 5.4 says write down the x-intercept of h if h of x is equals to p negative x. Now you have to understand this is what? This is on transformation. And then to be more specific, what kind of transformation? It's reflection, right? Now to be more specific, what kind of reflection? Whenever we see negative x here, this is a reflection on the y-axis, right? Now a reflection on the y-axis affects the what? The x coordinate, right? So whenever you see negative x there, it's the one that is being affected, the x coordinate. So that means it's a reflection on the y-axis. So what would be the x-intercept of h now if we have that, right? Remember, the x-intercept of originally, so this we would see it in terms of our graph. So understand that our graph for p was like this. And then we had our intercept at what? At 1. Now, what are they saying? If we have to reflect this along the y-axis, meaning we are reflecting it along this line, so the mirror image must be created over here. So now this will be indicating the mirror image that we'll have. So that means the mirror image has to be created over here. Now, what do you see? What becomes the x-intercept now? Negative 1. So if we have to take the same graph and reflect it over the x-axis. So note, our x-coordinate was 1. Now our x-coordinate is negative 1. So a reflection on the y-axis affects the x-coordinate. So that means, how do I write the x-intercept now? The x-intercept will now be shown as negative 1 is to 0. So those are the equation. That's the equation of the axis of the x-intercept. So originally, it was 1 is to 0. If it's reflected along the y-axis, it's negative 1 is to 0. So I hope that makes sense. So it was only for 2 marks. So that answer, for just writing the answer, you were just awarded 2 marks straight up, because you actually know this. You actually know that this is actually a reflection. So it's more like they're awarding you marks for knowing that this is a reflection along the y-axis, and what happens if something is being reflected over the y-axis. So, okay, now 13 marks in the bag. So we have those number of marks there. So if we are adding to our 51, we had this 12 here. We had this 12. And then also we have 13. So we are at 76. 76, it's half the mark. So that means when you reach your question 5, you have already answered half of the question paper in terms of your marks, because that's 76, that's half of 150. So that means if you are looking for something like level 4, master question 1 to question 5, right? Now, obviously, that is not to say that you won't know any questions from beyond that, but then we are saying master, at least aim to get about 60 something marks from question 1 to 5, so that you know that the remaining questions you are just answering in order to find those marks to supplement until you reach 75 or 80 marks. So that's how you collect marks. You know where your marks are, and you focus most of your energy where your marks are. Then, okay, we have question 6, which is a parabola. The sketch below shows the parabola f with turning point 2:3 and y-intercept b is 0:5, right? And then they say, show that the equation of the parabola f can be written as y is equals to half x squared minus 2x plus 5. So when we are looking at this, we can see that this is a question whereby we are given the turning point and then also one any other point. So from knowing that, we know that the formula that we have to use is the turning point formula, a and then x minus p square plus q, right? So if we apply that formula, we are going to get this. So remember, for the y and x, we substitute the any other point, meaning the coordinates of b. And then here, for p and q, remember the turning point is actually being represented by p being the x value and q being the y value. So the 2:3 here is actually p, this one, and then this is q, right? So this is x, and then this is y. Our y is 5, and then we are first looking for the value of a, and then this is 0 minus 2 square plus our q is what? 3, right? Then we can take this 3 over to this side. So that's 5 minus 3. And then here we will have negative 0 minus 2 is negative 2, and then square. That's going to be 4, right? So 5 minus 3 is 2, is equals to 4a divided both sides by 4. A is equals to 1 over 2, right? Now you can see that we are getting there. That's our a, right? So every time you are calculating, confirm if you are on the right path. And then from here, in order to find the equation, this is where we go back. We can either go back to that formula here and substitute the a, but this time around, we don't have to substitute x and y because we are now trying to get the equation. So it's 1 over 2 and then x minus 2. So we are only substituting the coordinates of PQ. So it's APQ, then plus 5. Now, already we know that if we have a square here, this means we must expand the expression to that. And then we can start solving the brackets according to our board maths. X squared, so x times negative 2, that's negative 2x. Also, this is negative 2x. So middle term will be minus 4x. Negative 2 times negative 2, it's positive 4, and then plus 5. So I hope my maths is not very quick. Then this is y is equals to half multiplied by this is half x squared. Half multiplied by negative 4, it's negative 2x. And then half multiplied by 4, it's positive 2. then plus 5, right? And then, oh, where am I getting the 5? Where am I getting the 5? It's actually 3. Sorry for that. Then plus 3, and then plus 3, plus 3, then plus 3. So it's 2 plus 3. Excuse me for that. Then half x squared minus 2x plus 5. Right. So there we go. So we can also see that the y-intercept is being well represented there. Right. So remember, whenever you have y is equals to ax squared plus bx plus c, the c here actually should represent the y-intercept. So you should always check if you find the same value here. So it is correct. Okay, now that was for 5 marks. That was for 5 marks, so correct. Then 6.2 says, without calculating the discriminant, give an appropriate reason whether the discriminant of f is positive, negative, or 0. Right. Then looking at this graph, so if we go back, remember we are revising. If we go back, if you have this, what does it tell you about your discriminant? Your discriminant is greater than 0. You have real but unequal roots. If you have this, so this is, let's say this is A, and then if you have figure B, let's say it touches 1 there. So figure B touches only this at one point. This would mean that your discriminant is actually equal to 0. You have real and equal roots. So there are 2 roots, but then they are equal there. And then you have figure C, whereby your graph is just floating like this. No roots. It's not grounded anywhere. So that means your delta x is less than 0. So this means that you have non-real roots. Non-real roots. So the condition that we are facing here is actually condition C, right? Whereby we can see that our graph is not grounded onto the x-axis. So that means this is where we have our discriminant being less than 0. So it's actually negative. Your discriminant less than 0 means that it is negative. Remember, less than 0 means negative, right? So why? Because there are no real roots. There are no real roots, non-real roots. Then we have 6.3. It says use the graph to determine the value of k for which the equation half x squared minus 2x plus 5 is equals to k has real and unequal roots. So they want where it has real and unequal roots. So where will it start having real and unequal roots? Now, this is what you need to note. Before anything, let's write our equation here in terms of the standard formula, right? So this becomes A is 1 over 2, our B is -2, and then our C is 5 minus K. Now we can calculate this one, but then we want to actually use the graph, right? So in other words, we are looking for where it will have real and unequal roots. And we did say that in order for this to have real and unequal roots, it must intersect at 2 points like this. So they must be real but unequal. So it must intersect at 2 points, and these 2 points must not be at the same place. Now, looking at this, we can tell that the y coordinate here is actually 3. So if we were to shift this a further 3 units down, exactly 3 units down, then you agree that the graph will somehow look like this. Now, obviously, if I shifted 3 units down, then even my y-intercept here has to shift 3 units down. So from 5 minus 3. So I'm shifting this 3 units down. So 3 units down. That means it's 5 minus 3. The intercept that I would have here would be 2. And then there it goes. Right. Now, If I were to shift this more than 3 units, so let's say I shifted 4 units, now you understand that the graph would then start to have 2 different intercepts. These are 2 real roots that are unequal. This is the condition that we want to obtain. So that means the only way that is possible is if we shift our graph more than 3 units downward. But then how are we going to indicate that? The K here, remember, indicates your Y progression, right? Your Y progression. So that means this is what you use to actually indicate the vertical movement of your graph, right? So I'm saying that my graph should be shifted more than 3 units downward, right? So that means my K has to be greater than 3. If my K is, let's say, 4, then this will be 5 minus 4, and then we will have something here at positive 1. But then the minute my y-intercept is positive 1, what is happening here? 2 intercepts. Even if I were to shift it and then now my intercept is 0 there, again, I have 2 different roots, right? 2 unequal roots. So you get that. So that means we are supposed to comment and say we are supposed to shift this 3 units downward. But then why is it K greater than 3 instead of K less than 3 if we are saying it should be shifted 3 units down? It's because here already there is a negative here. So remember, we must be subtracting a number here so that we actually find an answer that is lower than, right? So in that sense, if we have half x squared minus 2x and then plus 5, let's say my K is minus 3, right? If it's minus 3, it's just simply going to be here, right? But then if I substitute a number that is actually greater than 3, so 5 minus 4, now it's going to shift 4 units downward, meaning it will start to intersect here at 2 different points. So hence my answer is K must be greater than 3. The number that I have to subtract with here has to be a number that is greater than 3 in order that my graph will intersect at 2 different points. So I hope that makes sense. Now 6.4, they say the parabola is shifted vertically until the new y-intercept is the origin. Until the new y-intercept is the origin. Determine the equation of the new parabola. Now, if they're talking about the y-intercept being the origin, this means your y-intercept is actually 0. Remember, at the origin is where we have 0. Sorry, 0 is to 0. So in other words, this is what they are doing. They are shifting that graph to the point whereby it's now like this. To the point where it's now like this. Where's your y-intercept? It's now at 0. So that's what they mean by the y-intercept being at the origin. So, okay, meaning at this point, we should have y is equals to half x squared minus 2x. But then remember, I said, looking at this, the C here is actually representing the y-intercept. So that means it's plus 0. Now, obviously, if you know your math, you wouldn't be saying plus 0 because plus 0 is more like there's no number there. So you need to write your equation as y is equal to half x squared minus 2x only. Right? So obviously, the absence of a number here or a constant tells you that your y-intercept is actually 0. Right? So now we have the 10 marks. So this question here, this parabola question was more of a conceptual question. So not much of the calculation were in this question paper. It was just you knowing the properties of a parabola graph, right? So be careful of something like that. Okay, so now let's go to question 7. So at this point, we now have our financial maths. It's not the most favorite to other people. Then let's go to this question here, 7.1 says Sarah's investment earns interest at 11% per annum, compounded semi-annually. Mary's investment earns an effective interest of 11.42% per annum. Whose investment, Sarah or Mary's, earns a higher interest rate, a higher rate of interest per annum, right? So note that for Mary, we are already given the effective interest rate, meaning that for Sarah, we are just given the nominal interest rate. So now, the whole point of this question is that we should convert the nominal interest rate to effective interest rate and compare it to this one. So you see that you already know that most of the time when it comes to your questions in financial math, the first question they are going to ask you is nominal rate to effective rate. But this time they were smart in presenting that question. They did not make it obvious. So you can find yourself doubting that you should do that. But then here it is the same question. So whereby you have to apply 1 plus I effective is equals to 1 plus I norm over m to the exponent of m. To the exponent of m. Right. So now we want our effective interest rate. So we can just leave I effective this side. So I effective this side is equals to 1 plus I norm over m to the exponent of m, then say minus 1. Then at this point, you can start substituting. It's 1 plus your nominal. Remember, you don't write 11% just like that. You need to first divide it by 100. It gives you 0.11. So 0.11, they said it's compounded semi-annually, right? So semi-annually means that we have to have over 2 here, and then also we have a 2 here, then minus 1, right? Then at this point, you simply just punch all of that into your calculator. You get 11.30, right? So obviously, when you punch it into your calculator, it will give you decimals, which you then need to multiply by 100. So those decimals that you are getting, multiply them by 100, and then immediately, then you round off to 2 decimal places. So now, comparing this is for what? Sarah. So I effective interest rate for Sarah, but then Mary is earning 11.42%. So now in converting that to this, we can still see that Mary has the highest interest rate. So that means our conclusion is that Mary has secured a better interest rate. So Mary has secured a better interest rate. So right, 3 marks for that. Now, 7.2 says Buhle decided to start saving before retirement. She makes payment of 10,000 monthly into an account yielding 7.72% per annum compounded monthly, starting on 1 November 2016, with a final payment on 1 April 2026, right? So if you have checked out my video before, I did expand on this question. I will also drop a link on how I went on to this question and then break it down fully there. But then just here, let's calculate here. They say calculate how much will be in the savings account immediately after the last deposit is made. Now we can see that we are just given this here, 1 November 2016 to 1 April 2026. So we need to figure out how many number of months are in between 1 November 2016 and 1 April 2026. And then if you can just calculate that, you will find that the number of months in between is actually 114 months, right? So 114 months. Now, we are calculating the savings account, right? The amount that will be on the savings account, meaning that's a future value because this money is being saved up, right? So obviously, this is the case whereby we have to deal with a future value. So future value is equals to X, and then you write your formula. So that's 1 plus I to the exponent of n minus 1. So you can check your formula from the formula sheet. No marks are awarded for the formula, just for the substitution into the correct formula. Then your X, she's making monthly deposits of 10,000. So 10,000. And then we have 1 plus the interest rate that we are given. They said it's what? 10%. Let's go check. 7.72%. So 7.72% is going to be 0.0772 because we first divide that by 100, then divide it by 12, and then all to the exponent of 114 months, right? Then minus 1, and then all over 0.0772 divided by 12. Then if you punch all this into your calculator, you are supposed to get 1,674,501.44, right? So it's 1,674,501.44 cents. So this is the amount she is going to get after 144 months. Now, marks were awarded for substituting in the correct formula. Then marks were also awarded for having the correct value for I. So if you did this and then you said over 12, so that's correct. And then also the value of N, so finding those number of months, finding that it is actually 114 months. So make sure you go check that out. And then your answer, that one, right? So 4 marks. Now, 7.2.2 says at the end of the investment period, Buhle reinvested the full amount in order for her to be able to draw a monthly pension. You see this time around. So now Buhle is reinvesting this amount, but this time it's not to grow the amount. It is actually to withdraw from the amount. So that means we are no longer dealing with a future value problem. We are dealing with a present value problem, because now the annuity is decreasing. Remember, if the annuity is increasing, appreciating, that's future value. But then if we are now drawing from that annuity, then that's a present value, because the money is already there, and then the money is now being withdrawn in a monthly installments, right? So this is the case that we are dealing with. She reinvested the money at an interest rate of 10% at this time, compounded monthly. If she draws an amount of 30,000 per month from this investment, for how many full months will she be able to receive 30,000? So Buhle is now relaxing there on a beach. She's retired, enjoying her money. Then so the formula that we are supposed to use is obviously our present value. So let's go with that. So present value, and then x1 minus 1 plus I to the exponent of negative n. If you forget this formula, you have your formula sheet, it is there. Right, then remember, this same amount was invested, the one that we got from the future value. So it's 1,674,501.44, and then is equals to, she is withdrawing 30,000 per month, and then 1 minus 1 plus, the interest is now 10%, so 0.1 over 12. And then we are trying to calculate how many months will she keep on doing that, or how many months will she keep on withdrawing the 30,000 before she becomes broke and wish she can go to work again. Just kidding. Then if we do this, we are going to cross multiply here. So you need to be very quick with your maths here. So if you take this one, you cross multiply with that, this should give you 1,674,501.44, and then immediately cross multiplied with 0.1 over 12, and then you have your 30,000 here. So you can immediately divide by 30,000. Immediately divide by 30,000 here. And then you can immediately then minus 1. So I'm just showing you a quicker way to solve that. And then you can try to, okay, even if this one you don't solve it now, 0.1 over 12, and then to the exponent of n. Now at this point, you want to find the value for all of this. You want to just punch it straight up in your calculator. Then you will find that your value is actually 0.53486 wada wada. And then because this one will be a negative, you can just make it positive because here it's also negative. So we divide by -1 immediately. Then you have 1 plus 0.1 over 12 to the exponent of -n. Now at this point, you want to just log all of this. So -n is equals to log 1 plus 0.1 over 12. And then you write all of this answer here. Because it will be saved in your calculator, you can just say answer. Then you punch all of that there. Now, if you punch, it should give you a negative value. So it's negative 75.4 meant to say. Then you can divide by -1 both sides again. And then your n is 75.4, right? Now, obviously, this means that in terms of the full payments that you'll be able to make of the 30,000, it is only 75, right? So that means the 0.4 here is speaking to the term that she will make a final withdrawal, but then it will actually be smaller than the 30,000. You might find that it's only 10,000, right? So the full 30,000 payments or withdrawals that she'll be able to make are only 75. So we're going to say therefore n is equals to 75 full monthly withdrawals of the 30,000, right? So again, if you are interested in finding this one, and then where I explain it much more deeply, you can check out that video. Then, okay, now let's proceed to 7.2.3. Says after withdrawing 30,000 for 20 months, Buhle requires 1,500,000. Determine whether she can access this amount of money from this annuity, yes or no, right? So now we are looking at a case whereby now Buhle wants to withdraw 1,500,000 after withdrawing the 30,000 for 20 months. Remember, 30,000 is withdrawn for how many months? 75 months, right? Then she has already withdrawn for 20 months. Now, meaning how many months does she have outstanding? So that's 75 minus 20. We find that she still has 55 monthly installments that she can withdraw from, right? So 55 months withstanding, right? Now, from this 55 months that are withstanding, we can try to make this our n and calculate if she still has that money in the pension fund, right? If she still has this amount of money in the pension fund. So again, what are we using? It's still present value, right? Because we are trying to draw from that annuity. Then over I, the x, she's still trying to withdraw 30,000, and then 1 minus 1 plus 0.1 over 12. And then now let's check. We are trying to check the outstanding balance. So let me edit this. We are trying to check the outstanding balance for the remaining 55 months. Then it's 55 over 0.1 over 12. Then if you punch this into your calculator, the present value or the outstanding balance there will be telling us how much money does she have left to withdraw for the remaining 55 months. Then it's 1,319,260.60, which, looking at this amount that is left, that is outstanding, it is actually less than the amount that she requires. So that means the answer is no. She can't access that money because 1,319,260.60 is actually less than what she requires, which is 1,500,000. Right. So yeah, she poo-pooed the money. Bring back our money. Then, okay, that's question 7. Let's go to question 8. So 15 marks, 15 marks. Go practice that financial maths. Make sure that you actually get it, right? So work on your calculator skills and make sure that you are able to just punch everything into your calculator, because in so doing, guys, you are avoiding the whole paradox of having to round off, because the more you round off your values, the further you are getting away from the true values, right? So you want to learn how to just punch everything all into the calculator. Then, okay, we have question 8. It says determine f prime x from first principle. Oh, I actually don't like this question. Then, okay, now to determine this from first principle, we know that we first have to get the expression for fx plus h, whereby where there is x, now I have to replace by x plus h. Then that's negative 2 x plus h square, then plus 6x plus h, right? Then obviously you have to do your maths there. Negative 2, this becomes x squared plus 2xh plus h squared. At this point, you've already memorized that. Then plus 6 times x is 6x, 6 times h is 6h. Then you can start multiplying inside by the negative 2, negative 2x squared minus 4xh minus 2h squared plus 6x plus 6h. Now, are there any common factors? No, no common factors. So we're going to leave it like that. But then remember, our f of x is like that. So at this point, this is where now you have to do your lim thing. So f prime x is lim h approaching 0, f x plus h minus f of x over h. Then you always have to make sure that you don't forget that lim, because they might penalize you for that. So you have your whole expression here. You want to substitute it here. And then plus 6x plus 6h. Then you have to minus f of x. So because now we have substituted, let me erase it to make space. So now you have to substitute the whole equation of f of x, but then it's an expression, so make sure you don't forget to put it inside the brackets. 6x over h. Then this is lim h approaching 0. Then negative 2x squared will cancel out with that 2x squared. So negative and negative is positive. Then we have minus 4xh minus 2h squared plus 6x, which should cancel out with this negative, and positive is negative. So 6x. Then we have a plus 6h. So all over h. Then this is lim h approaching 0. Cancel this, cancel that. We are left with negative 4xh minus 2h squared plus 6h over h. Now we can see that we can take out h as our common factor. Negative 4x minus 2h plus 6 over h. Now at this point, h and h can divide out. So this is a lim h approaching 0, negative 4x minus 2h plus 6. Now, as soon as you want to substitute 0 to h, now you can drop off the lim h approaching 0. So now, at this point, you will say a negative 4x minus 2 and then bracket 0 plus 6. So you are left with your f prime x being equal to negative 4x plus 6, right? So, okay. Now, the trick to that is you can try to just solve it from here so that not that that's your answer, but then just to make sure that you get to the correct answer. So you first check it out using your what you call laws, right? Then you just go here, f prime x, I would say 2 jump down to multiply -2. It's -4x. And then here, I know that if it's just a variable of x here, then I should have the number there, so 6. Now, if you do it from here, you now have an idea of the answer that you should get. And then now you are just working towards getting to that value there. So it becomes much easier because if you start to make mistakes, then you are able to just fix those mistakes quick because you already have an expectation of an answer, right? So you can apply that trick. Now let's proceed. We have 8.2, it says evaluate dy dx if y is equals to 2x squared plus half x to the exponent of 4 minus 3. So this here, we'll solve it the way we know how. So it's just 2 marks. Exponent jumps down to multiply coefficient. It's now 4x. And then exponent jumps down to multiply coefficient. Then that is supposed to give us what? So what is 4 multiplied by half? It should be what? 2. So that's 2x to the exponent of 3. And then we know that if it's a constant, it's just 0. So that means our dy dx is that. So they mark, it's 1 mark for each. It's 1 mark for saying this. And then it's 1 mark for that. Now, f prime x, if f of x is this, right? Now, with this one, you have to be very careful. You cannot just start deriving here. You need to first make sure that your equation or your expression is prepared for derivation. So by saying that, I mean, if you need to factorize, then you got to factorize. So looking at this, we are given x cubed minus 5x squared plus 4x. Now over x minus 4. Looking at this, we can see that from these 3 terms, we have x. So meaning our x is our common factor. So we can factor out x, and then we are left with x squared minus 5x, and then plus 4, right? Over x minus 4. Note that I haven't derived yet. Now, I need to say this is x, and then I try to factorize this. Now, from factorizing, you know that this will be x minus 4, and then x minus 1. Now, the idea here is that every time you factorize, you will always have to divide something that is on the denominator here. So it's all a matter of having to cancel out this denominator. So that's the whole purpose of factorizing in this type of questions. Then this will divide out with that. So we are left with x and then bracket x minus 1. But then this we can multiply inside, that's x squared minus x. So this is our f of x. This is the expression that we need to derive. So we say at that point, our equation is prepared for derivation. So at this point, that's when I now change my f of x to f prime x. Now I'm starting to derive. So that's 2 multiplied by 1. So 2 jump down to multiply coefficient is 2x. Then minus 1, I'm left with the 1. But then here I have to take the coefficient. The coefficient of x is -1. So there we go. Okay, so now we are on 8.3. It says the tangent to the curve y is equals to 2x squared minus 3x minus 5 is drawn at the point 2 is to -3. A straight line parallel to the tangent passing through the y-intercept of the curve is then drawn. So let's pay attention to this. This other parallel line, this other straight parallel line passes through the y-intercept of the curve. Now, the curve we are talking about, this one is, is this one, right? Then the y-intercept of that curve is -5, as we can see from here, right? So we know that the constant represents the y-intercept. Now, let's try to have a sketch just to understand what is really going on here. So this here, as we can see, it's a parabola. So it needs to be concave like that. And then what they're saying here is that, so concave up, what they're saying here is that there is a line that is drawn parallel to a tangent. So our tangent can be somewhere here. So let's place the tangent somewhere there, intersecting at 2 is to -3. Right? So let's say they intersects there, 2 is to -3. But then now there's another line that has been drawn. It's not a tangent. This line has just been drawn across the curve, but then it's intersecting with the curve at y is equals to -5. So it's intersecting with the curve at the y-intercept. So this is -5 right there. So now what we know is that this tangent here is parallel to this straight line. So now I've just tried to take whatever that we have in the statement and represent this in terms of a graph, right? So now I hope we can clearly understand the question. So of course, these two lines are parallel. And then if these two lines are parallel, what do we know about parallel lines? We know that parallel lines have the same gradient. So in other words, the gradient that we're going to find for the tangent will be the same gradient as for the straight line, right? So let's call it SL, straight line. Then the gradient of the tangent to the curve will be equal to the gradient of that straight line that is parallel to the tangent. So that means in tackling this question, we can see that we can tackle it in terms of the gradient because that's what is common between those two lines. So if we want to find the gradient, we already know that according to what we know in cubic function, the gradient is actually being represented by the first derivative, say y prime, and then it becomes 4x minus 3. What I will have here is what I know as the gradient formula. So the first derivative is what we call the gradient formula, meaning that if I actually want to find the gradient of this straight line here, the tangent, what I can do with this gradient formula is just simply substitute the x coordinate of the tangent, right? Then y prime is equals to 4, and then my x coordinate is 2, then minus 3. Now, having to substitute the x coordinate will tell me the gradient of the curve at that particular point. So the gradient of the curve at that point is equal to the gradient of the tangent. This is where we get f prime x is equals to gradient of tan. So we're saying that the gradient that you're going to get from deriving here must be equal to the gradient of the tangent. So now my y prime is equals to 4 times 2, it's 8, 8 minus 3, that's 5. So in other words, that means the gradient of the tangent is equal to 5. Cool. But then now, one thing that we know is that the gradient that we're going to find from here is the same gradient here because they have the same slope, right? So if the gradient here is 5, then that means also the gradient of that parallel line is equals to 5. Now, in order to determine the equation of a straight line, your formula is y is equals to mx plus c, which tells you that in order to determine the gradient, there are two things that you need. I mean, in order to determine the equation of the straight line, there are two things that you need. Pardon me for that. So it's your gradient and the y-intercept. So you need these two. Now, the gradient, we have already got it from saying that these lines are parallel, so they have the same gradient. But then what is the y-intercept? When we read here, they say a straight line parallel to the tangent passing through the y-intercept of the curve. So this straight line here, that is parallel to the tangent, is actually passing through the y-intercept of the curve, meaning the point of intersection between that straight line and the curve is at the y-intercept. So we need that y-intercept. And then we want to take that y-intercept because this intercept is both the y-intercept of the curve and of that straight line. So just like that, we have our equation. It's y is equals to 5x minus 5. So you have your 4 marks like that. So let's see where your marks were allocated. So this is 8.3. They were going to give you 1 mark for knowing that you have to derive this. So for derivation, it's a mark. And then because now you understand, in order to get my gradient, I need to derive. Now also having to substitute the correct x value here, or the correct coordinate. So it's a mark. And then having to find your gradient as a 5, it's a mark. And then having to find your answer, which is the equation of the straight line, it's a mark. So that would be 4 marks in total, right? So also take this trick here. If you find that it is just written in terms of a statement, try to visualize what is happening and try to draw it in terms of a graph so that you can better approach the question. Okay, so done with question 8. Was only for 40 marks. So we know that question 8 is just that basic cubic, that basic calculus, differential calculus. Then when we go to question 9, that's where we then meet our cubic function. So question 9 says 9.1, determine the points on the curve of y is equals to 4 over x, where the gradient of the tangent to the curve is equals to -1. So where they say where the gradient of the tangent to the curve is -1. So they already gave us the gradient. But then remember, we already know anything that pertains to the gradient of the tangent, f prime x is equals to the gradient of tan. So which means, what is it that we need to do here? So we need to understand that we need to take this y is equals to 4 over x. So this can be written as 4x to the exponent of -1 in order to prepare it for derivation. So now we need to derive this dy dx, and then this will become -4x to the exponent of -2. So it's the exponent jump down to multiply coefficient, then subtract 1 from the exponent. Then from here, we are going to have our equation like this. But then remember, we've been told that the gradient dy dx is the gradient, because f prime x dy dx is the same as saying f prime x. So this should be equal to the gradient of the tangent. So we should equate this expression to the gradient. Then 4x, we can choose to write it like this, as with the positive exponent. Then if we cross multiply here, we have -x squared is equals to -4. Dividing both sides by -1, our x squared is equals to 4. Then we can square both sides like this. Then our x can either be equals to 2 or equal to -2, right? Now, if our x is 2 and -2, that means we also need to find 2 y values, right? So we're going to say, what is y? If x is equals to 2, then we want to substitute into the original equation. So whenever you are looking for the y coordinate, you then go back to the original equation of the curve. So this is y is equals to 4 divided by 2. So your y is equals to 2. That means this set of coordinates are 2:2. Now, if x is equals to -2, we have y is equals to 4 divided by -2, still substituting here. So my y is -2. That means this set of coordinate would be -2:2. Right. So that's how you were supposed to go about tackling that one. Oh, so 5 marks. Wow. Then where are the marks for writing it in exponential form? So you have a mark for writing it in exponential form. You were also awarded a mark for deriving. So derivative, it's a mark. And then you were awarded the mark for equating the derivative with -1. That means you understand this concept. Then you were awarded a mark for the x values, so getting all your x values correct, and then all of them, and then also getting your y values correct, all of them. So it's 1, 2, 3, 4, 5. 5 marks. Right. Then we have 9.2. It says the graph of the cubic function with equation y is equals to x cubed plus ax squared plus bx plus c is drawn below. And then point number 1 is telling us that f1, so f when x is 1 and then f when x is 4, is equal to 0. So this is telling us that 1 and 4 are actually the intercepts, right? So the x-intercepts should be more specific. So these two are the x-intercept, as we can see on the graph. Then f is the local maximum at point B, and the local minimum at x is equals to 4. We can see the local minimum, but then they're saying the local maximum is represented by B. So they did not show it on the diagram. That means we can put it there. So that's B, the local maximum. Now 9.2.1 for only 2 marks is saying show that A is equals to -9, B is 24, and then C is -16. Now from this, you have to understand that you do have the original equation for the cubic graph, which goes ax cubed plus bx squared plus cx plus d. Now understand what they did here. They simply just shifted the a to this to here, and then the b here, and then c there, right? But then this does not change that your c here is now standing for the y-intercept, and then where you have your a is where we normally have our b, and then where you have your b is normally where we have our c. So that means in terms of the original cubic function, you are given this coefficient here that would make up for A, right? So in terms of this, your A, B, and C are these ones. But then in terms of the original way of writing it, you are actually given your A, right? So that goes to, if you have to write this in terms of the root form of the cubic function, then this goes as x minus x1, x minus x2, x minus x3. The a that you are going to put in here is the a from the original equation, which is, from looking at this one here, we can tell that it's 1, right? Then we want to go ahead and substitute our intercept. So the first intercept is 1. But then also we know that this condition here, when we have our intercept being both the turning point and also an x-intercept there, then we need to repeat it twice, because this means we have 2 equal roots. So remember, all in all, your cubic function should have 3 roots. So you have this root here and then these 2 roots here, which are equal. So that means when you write them here, you need to actually repeat them twice. So x minus 4 and then x minus 4. So always note that if you are given something like this, with that one that is on the turning point, if it's both a turning point and an intercept, you need to repeat it twice. Then now we can go on with this. Obviously, we have a 1 here, which we can just write it like this. We know there's a coefficient of 1. Then let's deal with this brackets first. So deal with the second and the last bracket first. Then it's x squared. X times -4, it's -4x. And then -4 times x, it's also -4x. So when you add them together, that's -8x. -4 times -4, that's +16. Now at this point, we are left with just multiplying this bracket with all of this, right? So FOIL here, x times x squared is x cubed. And then x times -8x is -8x squared. And then x multiplied by 16, that's 16x. So now we're going to do the same thing with the -1. -1 times x squared, it's -x squared. -1 times -8, it's +8x. And then -1 times +16, it's -16. Now at this point, we can add or subtract the like terms. So we have this and that, and then this and that. So that's x cubed, -8x squared, minus x squared, that's minus 9x squared. And then 16x plus 8x, that's plus 24x. And then we have minus 16. So we have our equation like that. And then let's see if it complies to this a, b, and c. So the a, according to this, should be the coefficient of x squared. So a is -9, which is correct. And then b, according to this, should be the coefficient of x, so which is 24, it's correct. And then c, according to this, should be the constant. So this is -16, right? So we are correct, 2 marks, unfortunately. Okay, then let's move. We have 9.2.2. It says calculate the coordinate of point B. Remember, we said point B represents the local maximum there, right? So anything to do with the turning points, local maximum and local minimum, we know that if we are to calculate the turning point of a cubic function, we always derive first, and then we equate that equation of the derivative to 0, right? So always note that this is where we apply this concept. And then remember, we already have the equation. So it was y is equals to x cubed, and then minus 9x squared plus 24x, and then minus 16. Now, the first thing that we have to do is obviously derive this. So dy dx, and then that's 3x squared minus 18x, then plus 24. Now, we are supposed to then equate our derivative to 0. So this will be 3x squared minus 18x plus 24, because we are trying to find the coordinates of the turning point. Now, the reason we do that is because we say the gradient of the gradient at those turning points is actually equal to 0, because that's where you'd put a parallel line. Now, we all know that the equation or the gradient of a parallel line is always equal to 0, right? Then here, what you are supposed to do, all of this can be divisible by 3. So let's divide both sides by 3. So that is equals to x squared. And then here we have 6x. And then here we have what? 8, right? Is equals to 0. Now it's a matter of factorizing this. So, okay, let's check. Then if we factorize this one here, we are going to end up with x minus 4 and then x minus 2. So the factors of 8 that give you negative 6, and then it's equals to 0. So your x can either be equal to 4 or your x can be equal to 2. But then we see that we already have x is equals to 4, which was the local minimum. So the one for the local maximum at B should be 2. And then we can see that it confirms that because it comes before this value here. So it must be a 2. But then we are not done. We've only found the x coordinate. That means we need to take this x coordinate and go back to the original equation to find the y. Remember, every time we are finding the y coordinate, we always go back to the original equation. So that's y is equals to, where there is x, I'm going to put 2 and then cube, 9 and then 2 square plus 24. So where there is x, I'm substituting 2. And then you simply just grab your calculator. Make sure that you have punched everything correctly and as it appears. So you always have to double check that. And then your y is equals to 4. So that means your coordinates for B are now 2 is 2, 4. Right. So that's how you calculate that. Okay, so 4 marks for that. Again, where were the marks being given? So for 9.2.2, there was actually a marks awarded for the derivative. It's a mark. And then having to find the factors. So this here was a mark. And then having to find the, what you call the x values. The y values. So your y here being 4. And then also, again, being able to conclude that your B is 2 is 2, 4. So there was 4 marks. Okay, then they say 9.2.3, determine the values of k for which f of x is equals to k has only negative root. Now, let's look at this question. Okay, so remember we have our equation for f of x is x cubed minus 9x squared plus 24x and then minus 16. Then they say this should be equals to k. So if we want to write this in standard form, then we are aware that we need to bring the k over, and then that's minus 16 minus k, right, is equals to 0. Now we want to understand what value would we need to subtract here in order for this to have what? Only negative root. Remember, when we are talking about the root, in this case, we are talking about the x-intercept. Now we can see that at this point, it actually has 3 positive roots, right? So we have the 4. Remember, this here are 2 equal positive roots. So that's 4 and 4, and then 1. So these are all positive roots. Now we want to get to a point whereby we only have negative roots. We want to get to a point whereby we'll only have a negative intercept, right? X-intercept. Now you do understand that if we further push this graph downward here, then we won't be winning with this, because this is what will happen. So if we push it down, then this is what will happen. So we'll still have what? Positive roots. Now that means our chance of having negative roots is if we keep on pushing this graph further up, right? So if we keep on pushing it up, then we will get to a point whereby we push it up until the y-intercept here, let's say it's 0, and then now your graph will be looking something like this. But then once you push it beyond this point, right? So remember, originally its intercept is at what? Negative 16. So if you are pushing it upward 16 units, then it lands at 0. If you further push it up here, then there's an amazing thing that happens, right? If you push it beyond this 0 line here, the origin, then your intercept will be somewhere here. But then look at where your graph will be going now. It will be intersecting on the negative side of the axis, right? But then what happens? This other coordinate, there won't be any intersection with the x-axis. So that means we'll only be having this x value here, or this x-intercept here, being a negative root. So being a negative root. So in other words, if we want to determine that, we do understand that here we have to subtract with a number that will actually be less than negative 16, right? So how do we get to that? If we say negative 16, let's say we decide to subtract, let's say our k here, we decide to put 15. Let's start by a positive. Let's say we decide to put 15. Now, if we put this one here, this is only giving us negative 31, which obviously this means we are pushing the graph further downward. But then if we want to push it up, then we have to understand, because of this minus here, we need to substitute our k as a negative value. So what if we are substituting negative 15? Then you do understand that we'll end up with negative 1. So it will be somewhere here. But then remember, we want it to go beyond the 0 line. So if we are substituting exactly with negative 16, we are only getting 0, which is this case here. Right. Now, that means if I were to substitute with a value that is greater than negative 16, let's say now I'm substituting with negative 17 or negative 18. Let's try negative 18. So this would be negative 16 plus 18, which would give me 2. Now, if this is intersecting at 2, for example, that means this wing here will be touching on the negative x-axis, producing a negative root. So that means my answer for this one, for only this 2 mark, I was supposed to say when k is less than negative 16, right? So those are some high order questions. You actually don't need any calculations there, but then to understand what will happen if you shift the graph either up or down, right? So your value there was supposed to be k less than negative 16. I know a lot of you would be saying, I just leave there 2 marks. There is no way I'm working this hard for a 2 mark. Then, okay, 9.2.4 says, determine the values of x for which f is concave up. For which f is concave up. Now, remember, anything to do with concavity, you have to consult the point of inflection. So that is always the trick. Anything to do with point of inflection, we know that we have to consult the point of inflection. Now, I have a very easier way to find the point of inflection. If you understand that the point of inflection is only just the midpoint of this x-coordinate, the x-coordinate of the turning points, then you can easily get the x-coordinate of the point of inflection. So by simply saying x is equals to 2 plus 4, then divided by 2. So it needs to be somewhere here being a midpoint, right? So 2 plus 4 is 6, 6 divided by 2, that's 3. So my point of inflection actually is x is equals to 3. But then remember, I'm looking for where it is concave up. Now, concave up is this type of shape here. This is a concave up shape. And then here, this is a concave down, right? So it's very easy to remember that if it's smiling, that means it is concave up. If it's sad or frowning, that means it is concave down, right? So you can see, if you think of it like that, you can easily remember it. So if we're saying our point of inflection is 3 here, when do we start to see this shape? Is it before the point of inflection or after the point of inflection? Then we can see that it is after the point of inflection. So that means if it's after the point of inflection, we should actually indicate this area here, then x greater than 3, right? So look at that. So it's x greater than 3. So that means this curve is actually concave up when x is greater than 3, right? If it was asking where is it concave down, I would say it's before 3, so that way. So this would be x less than 3 if it was saying concave down. But now it's only saying concave up. Now, obviously, if you don't know this method of quickly finding your point of inflection, that means you have to do it traditionally. So traditional is whereby you start writing your f of x, x squared minus 9x squared, x cubed, minus 9x squared plus 24x, and then minus 16. And then at this point, you have to realize that you have to first derive this to the first derivative, which is, we did that one, 3x squared minus 18x, then plus 24. But then remember that the point of inflection is found on the second derivative. So anything to do with point of inflection, that means we consult the second derivative, right? So this one is always found on the second derivative. I almost said second difference. Then f second derivative now will become, so second derivative is when we derive the first derivative. So here, not 9, that's 3 times 2 is 6x, and then here we have minus 18. But then the second derivative, in order to find the point of inflection, has to be equated to 0. So also note that. So it's a bit of a process if you're going to do it the traditional way. Then 6x is equals to 18, divide by 6, divide by 6. Again, my x is equals to 3. Then you would then conclude your x is greater than 3. This is where it is actually concave up. So if you know this method, then you can see that it's bit fair for the 2 marks. But then to do all of this for 2 marks, nah, not on. So yeah, that means adopt this formula here. Adopt this. Just know that if we are looking for the point of inflection, it is always you take the x coordinates of the turning point. The x coordinate of the turning point, you add them together, then divide them by 2, because you are actually looking for the midpoint of those coordinates. Then, okay, now we have question 10, so we know the deal with question 10. Most of you just skip your question 10 because it's, what do we call this topic? Optimization, right? So optimization, a lot of you don't like optimization. Then question 10 says the diagram below represents the graph of y is equals to x squared and rectangle PQRS. Point P is a common point on both the graph and the rectangle. So as we can see there, point P, it's both on the rectangle and on the curve. Then the graph of x is equals to 6 and y is equal to 0 represents 2 adjacent infinite lines of rectangle PQRS. So they're saying that infinite lines. Then the coordinates of point 6 is to 0 and point 6 minus x is to 0 are given. Then, okay, write down the coordinates of point P in terms of x. Now, that one is quite simple. So all you have to understand here is that if you look at P in reference to Q, you can see that they lie on the same straight line, on the same vertical line, to be more specific. Then that means if that is the case, they share the same x coordinate. So the x coordinate for P would be the same as the x coordinate for Q, that's 6 minus x. But then what would be the y coordinate of P? Since it's attached to the line, to the curve there, we know that the equation of the curve is y is equals to x cubed. So x, not x cubed, x squared, meant to say, sorry for that. So our y coordinate will be represented by x squared, right? So if we want to find the y coordinate, given that our x coordinate is this, now you understand that where there is y, I would need to substitute my x coordinate, which happens that my x coordinate is actually 6 minus x. Then this would be 6 minus x squared. So that means my P coordinates are actually 6 minus x is to 6 minus x squared, right? So this would be representing my x coordinate and this my y coordinate. So I hope it makes sense, right? So it's coming from here. Now, 10.1 says write down the 10.2. So that's the coordinate 1 mark. Write down the maximum. 10.2, it's determine the maximum area. So this is still applying the concept of the cubic function, whereby if you see maximum or minimum, you know that you have to derive. So it's f prime x, and then you equate it to 0. So it's still applying that concept. Then area of rectangle PQRS. So now I want us to extract out this triangle. Let's extract out a P, Q, R, and then S. Now, agree with me when I say that the distance between Q to R must actually be X, because if you check this, this is 6 minus X, and then this is 6 here. Now, if we were to find the distance in between here, I would say 6 minus 6 minus x, because this is an expression. So what is 6 minus 6? It's 0, but negative times negative, it's positive, so it's x. So the distance in between Q to R, let's say it's x, which obviously, because this is a rectangle, also here it's x, right? But then if we are to consider this, remember the y coordinate of Q is 0. But then what is the y coordinate of P there? It's 6 minus x, and then all squared. So again, if we were trying to find the distance in between here, I would say 6 minus x squared minus 0, which you do agree it would still be 6 minus x, and then square. So that means this length here would actually be represented by saying 6 minus x and then square, which would be equal to this length here, 6 minus x and then square. Now we know to determine the area of a rectangle, it's the length times base. So considering that this is our base, and then let's say maybe this is our length, all we need to say is length multiplied by base, right? So we already know that. So at this point, this is what we can do. Our area in terms of x will be equal to length times breadth. Our length is 6 minus x and then square times the base is x. So I hope you all are following. And then this means I have to expand this. So 6 minus x and then 6 minus x times x, right? So I can just write it like that. Now I can deal with the brackets BODMAS. So this will be 36. 6 times negative x is negative 6x. And the negative x times 6, it's also negative 6x. When you add them together, negative 12x. Now what is negative x times negative x? That's positive x squared. Then I still have this x outside here. Now I can multiply inside with this x, which will give me 36x minus 12x squared, and then plus x cubed, right? And then because I want to deal with this in a way that I'm used to, let me just arrange x cubed minus 12x squared, then plus 36x. Now remember, we said from this concept, if we are looking for the maximum or the minimum, we have to derive and then equate to 0. So we have our area in terms of x, but then we want to apply this concept. That means we'll have to derive our equation of the area. So a prime x, then this will become 3x squared, and then 2 jump down to multiply this, that's minus 24x, and then plus 36. But then for maximum area, our a prime x has to be equated to 0. Our derivative has to be equated to 0. So that means at this point, I take the equation of the derivative, and then I simply equate it to 0. Now, I can see that all these numbers in here, 3, 24, and 36, are divisible by 3. So let me divide both sides by 3. So this will leave me with x squared, and then minus, what is 24 divided by 3? It has to be 8, so minus 8x. And then what is 36 divided by 3? It has to be 12. And then it's equals to 0. At this point, I need to factorize this. So this will become, so come over here. then x, the factors of 12, that will give me 8 here. So it's 6 and 2. So x 6 minus 2, and then x minus 2 meant to say x minus 6, and then x minus 2 is equals to 0. Then x is equals to 6, or x is equals to 2. But then here, there is actually a catch. We can't use 6, because if you come in here and you say 6 minus 6, this will give us 0. But then to say that q here is at 0 would be incorrect, because as we can see here, q is not at the origin, right? Q is somewhere here, a distance apart from the origin. So that means x is equals to 6 will not be a valid value, right? So this is not applicable, right? So that leaves us with 2. If we are left with 2, again, remember we are trying to get the maximum area. So how do we get the maximum area? By going back to the equation, right? So remember, we do have the original equation there. So the original equation is given as this. So if we take our 2 here and substitute it into the original equation, we can get the maximum area, right? So by simply saying, so this is it. We have our, okay, so based on this, let's check. So we can go back there and say we want to find our maximum area. And then this will be, we are given 36 x minus 12x squared, and then plus x cubed. So since now we are accepting x as 2, so we'll say area when x is 2, this is 36 and then 2 here, and then this is what we have, 2, because this equation now represents the area, right? Now all you have to do is take your calculator and then just press all of that into your calculator. So that's 36 multiplied by 2 minus 12 and then 2 square, and then plus 2 to the exponent of 3. And then when we punch all of that, the value that we get is 32, right? So it should be 32 units square, because it's the area, right? Now another one could have chose to say, I have my x here is 2, and then let me calculate the value that I'm going to get from here. So you could substitute 2 here, and then you will have bracket 6 minus 2 and then square. So this one here, if you substitute that 2 inside here and also don't forget to square, you'd get 16. Again, if you go back and say length times breadth, this is 16 multiplied by 2, which still would give you 32 units squared, right? So this is how you could have done that. Either you go back to the original equation to substitute your x value, or you substitute it in here as your length and your base, and then you then calculate area using area is equals to length times breadth. Okay, so that's how you were supposed to go about tackling that question for 5 marks. So again, let's check where your marks were awarded. So the awarded marks for the correct substitution into the formula here. So, and then they awarded the mark for having to derive. So you understand that you needed to then derive this. So it's a mark here. And then also, they awarded a mark for equating the derivative to 0. Very important, right? And then you also had a mark for the choice of the x value. So if you canceled out this one and then you actually chose x as 2, there's a mark for that, for having to say that 6 cannot apply as a value. And then there was a mark for the answer then. So 1, 2, 3, 4. And then there was a mark for finding 32 units. So 5 marks. Okay, so that's how you were supposed to go about answering that question. So it's a very interesting question. So give it a try, guys. Give it a try. You can check out some of my videos on this topic. Maybe you can try to understand it before you write, and don't just throw the towel when it comes to that easy marks. Okay, so now we are here. We are here. Given that A and B are independent events, they are independent events. So it's important that you note independent events. Now, PB only is 0.3. PA and B, the intersection is 0.2. P of A only is X, and then P of not A or B. So this one, that means it is outside, right, the event. So we are given events A and B. Let's indicate our Venn diagram. So this is A, this is B. They said the intersection A and B is 0.2. And then they said PB only is 0.3. So the 0.3 is perfect here. No, it's PB. So it's 0.3 this side. And then here we are supposed to have X, P of A only. Now, not A or B means it is not here, it is not here. So if it's not in either of the events, then it has to be outside of the event. So our Y is there, right? Now, this says determine the values of X and Y. Okay, so from independent events, what is it that we know? We know that for independent events, probability of A and B should be equals to probability of A times the probability of B. So every time you are working with independent events, that's what you should know. The intersection is equals to you having to multiply the two events. Now, A and B is 0.2. So let's say we have 0.2 here. And then what is the probability of A? So remember, when we are talking probability of A, we are talking all of this, not A only. So it has to be the X plus the 0.2. So that's X plus 0.2. Then multiply that by the probability of B, which the probability of B, we have all of this, not the 0.3, because that's PB only. So it has to be the 0.2 in along with the 0.3. So this is giving us 0.5. Right. Now, what we can do now is, let's write it here 0.2, and then X plus 0.2, and then times 0.5. Let's get rid of this 0.5 by dividing both sides by 0.5. Right. So we have 0.2 divided by 0.5. So 0.2 divided by 0.5. This is giving us 0.4. So this side we are left with X plus 0.2. Now, if we want to calculate X, that's 0.4 minus 0.2. So our X value is 0.2. So that means we have found the value of X. Here we are supposed to have 0.2. Right. So 0.2. But then how would we find Y? Now note that with Y there is not A or not B. If we are using our knowledge of complementary events, we know that probability of A plus probability of not A would have to give us 1. So here we are given probability of not A or B, meaning that using that concept of a complementary event, if we have probability of A or B plus the probability of not A or B. So not A or B means it's not here and it's also not there. So it does not belong in any of the events. So this should give us 1. So meaning if we want to find the probability of not A or B, we should say 1 minus the probability of having A or B. So we are just making it the subject of the formula. But remember, we can get the probability of A or B. So to then calculate that one, we say 1 minus probability of A or B is when we add everything up here. So you say 0.2 plus 0.2 plus 0.3, right? So let me try to write it visible. So probability of A or B is when you add everything up here, 0.2 plus 0.2 plus 0.3. Now when you add all this up here, it gives you 0.7. And then 1 minus 0.7 is actually giving us 0.3. Now that is equal to Y because probability of not A or B is Y. So therefore, in other words, Y is equal to 0.3. So there we go. Now to confirm that everything is correct, when you add everything up here, your sample space should be equals to 1. So we can see that if we say 0.2 plus 0.2 plus 0.3 plus 0.3, we do get 1. So that's how you were supposed to solve that. Nice. Then, okay, done with 11.1. So how many marks was that? 4 marks. So let's check where the marks were awarded. So for the one in which you were trying to find X, they gave you a mark for having to write that PA and B is equals to PA times PB for independent events. So it's a mark for that. And then if you didn't write it, but then you just choose to multiply like this, it's also a mark. And then having to find the X value, it's a mark. Then when it comes to the one for Y, if you know that the sum of the probabilities is equal to 1 here, and then you did something like this, it's a mark. So having to use that complementary event, it's a mark, and then having to find the Y value as 0.3, it's a mark. So 4 marks. Then, okay, 11.3, 11.2 meant to say, says the 6 players of a volleyball team stand at random positions in a row before the game begins. X and Y are 2 players in this team. Determine the probability of X and Y, the probability that X and Y will not stand next to each other. So also this question, I've done it before. If you are interested in finding more about it, I will also drop the link below on the description of the video so that you can go check it out. Then, but then this is how you were supposed to do this. So number one, let's consider what is happening here. We have 6 players, right? And then we are trying to determine the probability that X and Y will not stand next to each other. Now, that one would be a very daunting task, and then you might end up not even getting it. So what you want to do is you want to be smart with the approach of this question. You also want to use your knowledge of complementary events. Remember, we are still doing probability. So we are trying to determine the probability that X and Y will not stand next to each other. But then what could be easier is determining that X and Y will actually stand next to each other. Then we use the fact that if we say probability of X and Y plus the probability of not X and Y, then this here should give us what? 1. Right. So this is complementary event. So that means, in other words, if we are looking for the probability of not X and Y, then this should be 1 minus the probability that X and Y will actually stand next to each other. So our mission here would be to find the probability that X and Y will stand next to each other. Then we subtract that from 1. And then what concept are we using? Complementary events. Right. So it is very, very crucial that you go back and revise that on complementary events, because they like questions that are around that. Okay, so now let's say our mission is to determine that X and Y will be next to each other. So we have 6 players, 6 blocks, 2, 3, and then 4, and then 5, 6, 1, 2, 3, 4, 5, 6. Right. So suppose that X and Y must always stand next to each other. That's X, that's Y, right? Meaning that the other remaining players can be arranged in any particular order, right? So we can arrange these other players here. So these are other players which do not have any conditions, right? They can be placed there. They can just be placed there randomly. So, but then we already understand the concept of grouping, right? So since X and Y must always stand next to each other, they must always stand next to each other according to the way we are approaching the question. They must always stand next to each other. We are going to take these 2 as an item. So this is now 1 item, right? So meaning that in our mind, we no longer have 6 players, we have 5 players. Because remember, we are taking this one as 1 item, and then 4 other players are remaining. Now, if this is, we are taking this as 1 player, so X and Y is more like 1 player, because wherever they go, they'll be going together. So that means I actually have 5 players, right? So I actually have 5 players. So that means I will indicate this and then say, if that is the case, this is what I have. So let me indicate with a different color. So if that is the case, this is now what I have. So 5 players. 1, 2, 3, and then 4, 5. Right. Okay, so if I'm taking this one as 1 item, I do understand that it will be player X and player Y, right? But then also player X and player Y can be arranged in 2 different ways. So that means 2 factorial ways. I can either have player X then Y, or have player X then player Y then player X. So these are the two different ways in which I can arrange these two players that I've taken as an item. It can either be player X then Y, or player Y then player X. So this is known as two factorial ways, two different ways of arranging them. Okay, so suppose that here I have XY, right? So which can also be arranged as YX. Then the other players can follow here. So that's the case there. Now, if we are taking that one as one item, how many places do I have to fill? It's 5. So that means how many options do I have to fill in here? 5. If these ones are already standing there, that means I'm only left with how many? 4. If these ones are already standing, that means I'm only left with 3. And then this one here only left with 2, and then this one will only have 1 option, right? So these are the different ways in which I can place all those players, right? If I take my X and Y as one item. But then remember, this translates to what? 5 factorial. But I need to also remember that with the one player that I took as an item, or the two players that I took as an item, they can be arranged in two different ways. So that's where I say 5 factorial multiplied by the 2 factorial. What's the 2 factorial for? Is the fact that I can have XY or YX. So there are 5 factorial ways in which I can place them randomly there. But then there's 2 factorial ways in which I can place X and Y. Okay, so, but then remember, I'm trying to determine the probability. So the probability must always be over the sample space. Now, the sample space must be indicated by just arranging these players randomly in any fashion, right? So if I were just to arrange these players in just any fashion, right? So this would be 6, 5, 4, 3, 2, 1. So I'm not trying to make X and Y not stand to next to each other or stand next to E. I don't care what happens. I'm just placing them randomly like that. So this would be representing the sample space. So the sample space would actually be 6 factorial. Now, if I want the probability that X and Y would actually stand next to each other, then I would have to take 5 factorial multiplied by 2 factorial, then over 6 factorial. So this will represent that X and Y would actually stand next to each other. Now, if we have that, if we are using this concept now, the probability of not X and Y must be represented by saying 1 minus the probability of X and Y. So that means in order to find the value to that, I need to then say probability of not X and Y is 1 minus the probability that we will have X and Y. So over 6 factorial. Now this is where you say 1, and then you punch this into your calculator. So you want to punch 5 factorial times 2 factorial over 6 factorial. Then that gives you 1 over 3. Now if you say 1 minus 1 over 3, this will give you 2 over 3, right? So the probability that X and Y will not stand next to each other is 2 over 3. So that's how you were supposed to go about tackling that question. So it's all a concept of complementary events. Of 11.3, it says determine how many 4-digit numbers can be formed from 10-digit 0 to 9 if repetition of digit is allowed. Right. Now, the one thing that you have to consider with this question is that as much as they did not mention it here, you can't have your digit starting with a 0. Because if, for example, you have 0 and then followed by 394, what you actually have is a 3-digit code because the 0 here will not be counted, right? So here, they were supposed to mention it that 0 must not be the first digit. So 0 must not be the first digit, right? So that means if repetition is allowed, we have 4 spaces in between. Then out of a 10-digit, that means on the first block here, you only have an option of choosing from 9 digits, excluding 0, because 0 cannot be the first digit. So it's 9. But then your 0 can go in here, so you can have a number like 3094. As long as the 0 is in any of the positions besides the first position, then it can be counted. Right. So that means I will have 9 and then 10 here, 10, 10. So for these 3 other spaces, I can use all the digits. But then only for the first digit, I must be cautious of not having a 0 there, which is why I'm only having an option of 9. So that's your 11.3.1. Then for 11.3.2, for 11.3.2, they say repetition of digit is not allowed. So if repetition of digit is not allowed, that means if you use a particular digit, you are not supposed to use it on the next space, right? So that means again here, on the first one, I have only an option of 9. But then remember there are 10 digits. So here, if repetition was allowed, I was going to choose from 9. But then I have already put a number here from 1 up to 9. So that means I can't repeat that number there. If it was a 5 that's in here, I can't repeat it. So that leaves me with a sample space of 9. And then here, because if I already put in this 2, I'm only left with 8. So I have an option of 8. And then if I've already put 3, then I'm only left with options of 7, right? So that means I have to say 9 times 9 times 8 times 7. And then this here will give us 9 times 9 times 8 times 7. This is supposed to be 4,536, right? And then also going back to the last one, the 11.3.1, I think I didn't write an answer. It's 9, it's 10, it's 10, and then it's 10. When you multiply these ones, you are supposed to get 9,000, right? So don't forget to also multiply them and get the answer. So 9,000, especially if it's 2 marks like that, that means they also want you to get the answer there. Okay, so that's it. And then 11.3.3, the last digit must be 0 and repetition of digit is not allowed. So here, they're placing a condition that the last digit must be 0. So by all means, you must have your last digit being 0. So that means there's only one way in which you can fill this, by putting a 0. So you start with the condition. And then here, remember, you have an option of 9 digits because you should not have a 0 here. No 0 allowed, right? So this is 9. And then from the ones that will be remaining, that means you'll be left with 8. Remember, you would have put a value in here and then also a value there. So that means you are only left with 8 digits to choose from. Now, if you have already put these 3 digits, you are only left with 7. Then what you are supposed to do is say 9 times 8 times 7 times 1. And then let's find the value. So you grab your calculator. That's 9 times 8 times 7 times 1. And then we find our value as 504, right? So that's 504. So that means we can only have 504 digits on 4-digit numbers with that condition, right? And then that's how you were supposed to tackle that question, all for a total of 14 marks, right? So I would not really advise people to put in much of their time into practicing the counting principle, especially since you just did it recently. So you might find that the marks there do not even exceed 10 marks or 8 marks. So if you count these ones, that's 2 and 2, that's 4, 5, 6, 7. So that's 7 marks. So know that basic, it was not 7, it was 10. Oh, also this one is counting principle. So yeah, know that basic in terms of this. So it does not exceed 10. Know the basic in terms of answering those questions that will be straightforward to you. But then don't spend hours and hours trying to practice counting principles. You can just check a few videos, check a few exercises, but then put your time and effort where it matters, right? Where you know that you can get a lot of marks. Your cubic function, your functions as a whole, your parabola, hyperbola, exponential, put a lot of work there. Put a lot of work into your financial maths, and then question 1, 2, 3, algebra, and the number patterns. You must always make sure that if you don't get 100% in all of those, just make sure that at least you aim for something like 90-something%. right, in all those questions combined. You are looking at 50 marks starting from question 1 all the way to question 3, guys. That's 50 marks. And then now, if you have written question 4 and question 5, you are now at 50% of the paper. That's 75 marks. Now, if that's your goal, 50%, then you know that you only need to check a few in terms of your parabola, and then in terms of this here, and then you can also try to score your question 8 here, which is most of the time it is not that very difficult. Then you can at least push your marks to about 90 or 100. So if you get 90 divided by 150, that is actually a 60%, guys. So if you get 90 something marks, that's actually a 60%. That would be a level 5. Right, and then if you want 70%, then you have to aim for something like 105 marks. So you get 105, you get something to 115, you are somewhere there, level 6. And then if you are aiming for a distinction in this paper, then you know that it's 120 plus, right? So get anything from 120, and then above 120, you walk out with your distinction. If you want 100%, go for it, right? But then that's all, guys, with our practice or our prelim preparation. So all the best. I hope that you get the marks that you are aiming for. It is very important that you have an aim whenever you are writing a paper, so that you know how to scale it until you get those required marks. So with all that being said, guys, please press the thumbs up button if you've enjoyed the lesson and then you found it helpful. And if you've been watching the videos and haven't subscribed yet, please hit that subscribe button. But most importantly, please share the link with your friends and classmates so that they may also find assistance. Remember, do not be selfish. We are winning as a team.